Lesson 5.2, Sum and Difference Formulas. The cosine of the difference of two angles. This formula can be found on page 661 of your book. The cosine of alpha minus beta is equivalent to the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. We can use this formula to find the exact value of the cosine of 15 degrees. So what we want to try to do is rewrite 15 degrees as a combination of two angles that are being subtracted. Now, since we have special right triangles, the 30, 60, 90 right triangle, and the 45, 45, 90 right triangle, we want to try to rewrite 15 degrees as a combination of subtracting two of these angles. So 60 minus 45 would be 15 degrees. Now you can also do this another way because you could use 45 minus 30 as well, and it will come out the same. Any two angles that you can subtract that give you 15 degrees will work. I'm just going to start with the cosine of 60 degrees minus 45 degrees. So according to this formula, I want to take the cosine of the first angle times the cosine of the second angle. So I'm going to take the cosine of 60 degrees times the cosine of 45 degrees. And then the second part of this formula, I'm going to use the sine of the first angle times the sine of the second angle. And then these numbers I'm from, like for example, cosine of 60 using SOHCAHTOA. Cosine is the adjacent over the hypotenuse. And so that's where I'm getting this from. The cosine of 45 degrees, I'm using this triangle. It's going to be the adjacent over the hypotenuse, but when I rationalize the denominator, I get radical 2 over 2. So I'm using those special right triangles and filling in the values, and then you just have to do some arithmetic. When I multiply these two together, I get radical 2 over 4. When I multiply these two together, I get radical 6 over 4. And so then if I add radical 2 over 4 to radical 6 over 4, I get radical 2 plus radical 6 all over 4. There's another formula for the cosine of the sum of two angles. And that is going to be that the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. So if you want to find the exact value of the cosine of 105 degrees, once again, try to find two angles from our special angles that will add up to 105 degrees. And that would be 60 degrees plus 45. So I'm going to set that up and I'm going to plug it into this formula. So I'm going to want the cosine of 60 degrees times the cosine of 45 minus the sine of 60 times the sine of 45. Fill those in, and then do your arithmetic. This is the square root of 2 over 4. This is the square root of 6 over 4. Put it together, and it's the square root of 2 minus the square root of 6 over 4 is equal to the cosine of 105 degrees. Then we have special formulas for the sine of the difference of two angles. So the sine of alpha minus beta is equal to the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So they're just using the Greek letters alpha and beta to represent two different angles. We could call them A and B if you prefer. So to find the exact value of the sine of 15 degrees, if we want to do a subtraction, we're going to try to find two angles from our special angles here that subtract to give you 15 degrees. And you can use 60 minus 45. So 60 becomes our alpha, 45 degrees becomes our beta, plug it into the formula. Everywhere you see the first angle, you put 60. The second angle, you put 45. And then using your special right triangles, the sine of 60 is radical 3 over 2. The cosine of 45 is radical 2 over 2. The cosine of 60 is 1/2. The sine of 45 is radical 2 over 2. Do your arithmetic. This becomes the square root of 6 over 4. This becomes the square root of 2 over 4. And then you subtract them, and it becomes the square root of 6 minus the square root of 2 over 4. The sine of the sum of two angles. The sine of alpha plus beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So to find the exact value of the sine of 105 degrees, use 60 degrees and 45 because that adds up to 105 degrees. Plug in 60 for alpha into the formula, plug in 45 for beta, plug in the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. This is going to be radical 6 over 4. This is going to be radical 2 over 4. When you add them together, it's the square root of 6 plus the square root of 2 all over 4. And then you have some formulas for tangent. The tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta all over 1 minus tangent alpha times tangent beta. The tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. So if we want to verify the identity that the tangent of x plus pi is equal to the tangent of x, once again, anytime we verify an identity, start with the left-hand side of the equation and rewrite it. And then we're going to simplify this using our formula, this one right here, where we're adding alpha to beta, but this time my alpha is x and my beta is pi. So I'm going to plug it into that formula, and this is what I'm going to get. And then from here, we know that the tangent of pi is 0. I know that from the unit circle. Pi is also 180 degrees. It's a half turn. When you turn halfway around the unit circle, you land at the point -1, 0. But the tangent is the y-coordinate divided by the x-coordinate. So that's where I'm getting 0 from. Or you can just punch it in your calculator, making sure you're in mode radians. So I can replace the tangent of pi with 0. And so 0 times this is just 0. So I basically have the tangent of x over 1, which is the tangent of x. And you are finished when you end up with the right side of the equation.